No. Let me restart. No. Alright, I'm stuck in vertical mode yet again. I was so close to getting it right this time. Morning, Carlos. So, I've had some requests to take this thing apart and look at the electronics and the hot end and just kind of see what's going on here. So that's what we're going to do. Strongest USB-C powered stepper motor. Yes, thank you very much. It was quite a feat of engineering. Okay, so today we're gonna take this AnkerMake M5C apart and see how it's built. As you can see, I already got started a little bit there, but let's do this job thoroughly and leave no stone unturned. And anyone who has questions about what you want to see on this machine, just make sure to drop it in the comments. I'm planning on taking everything apart, and we should have a pretty good understanding of how it works by the end. So last thing I want to get before we get started here is the toolkit so I can undo Allen screws and stuff. So I'm going to grab that. I'll be right back and we'll get started. And I'm going to be using the toolkit they provided with the machine. So yeah, this is everything you need. Alright, can we get a speed run? I'm not sure if I can do a speed run. And no, it's not broken, it works fine. I'm just wanting to take it apart to see what's going on in here. So let's get to it. I'm also running my Ender 5 Max over there. Or no, not Ender 5, it's K1 Max. I'm printing something for an upcoming project. I've got some ABS on the spool there, so hopefully that'll work. And we'll check in on that periodically throughout this stream. So, how's the audio, everyone? Is this okay? I mean, if it's not okay, that's too bad, because that's just the way it is. Alright, so first things first, we've got a nozzle here. This is the spare nozzle. So let's take some calipers to that and see what size they're using. Alright, my calipers are out of battery right now. So much for that. But from what I've read online, it's a 1 centimeter spacing between the top there and the nozzle. Video quality is poo-poo. Yeah, I know. I'm using the internet on my phone, and I don't want to pay for internet, so we're just using like cellular, which kind of sucks, but oh well. Okay, so let's get to it. Yeah, so I'll give you a hint as to the upcoming project. I'm working on an axe that's 3D printed. And I've got some other projects that I'm cooking up right now too. They should be pretty cool. Okay, well, I was going to, you know, heat that up and take it apart, but I'm just going to take this off right now because this is going to be annoying. All right, so zoom out and we'll start taking this apart. So, even the blade is 3D printed? Yes, the blade is 3D printed. It's 3D printed out of metal though. All right, printer project we talked about on Discord? I'm not sure. I have a lot of secret projects, so don't spill the beans on that one, Wombat. Okay, so yeah, this top comes off very easily. It just kind of pops off. And then we've got another one of these mini stepper motors. They're using like a smaller size stepper motor than normal, which is smart. There's no reason to use a large stepper motor because that just adds extra weight. And it has extra torque capacity that you're not using, so yeah. And this stepper motor has some weird stuff going on. We've got a 5-pin cable going to it, and then they've grounded the little stepper motor wire. Let's get a look on this side. Holy cow. So over here, that's stepper motor, little baby one, and it's driving this big gear. So that's your gear reduction. And then there's some more small fans. So they're using small fans all around on this thing. Now, let me lower this tripod down a little bit. Unfortunately, I'm not using my Flexi Spot desk today, although I should be. But then I wouldn't be able to check on my my other stuff that I've got going on here. Okay, so let's take this apart. I'm fumbling. These screws are kind of hard to take out. They might have used some kind of Loctite to hold everything in place. And actually, you know what? Now's the time. I think we're going to have to put our first mod on here. All right, so that's unscrewed. Let me grab something that I want to install on this machine. I got this box from Noctua. Can anyone guess what's in here? It's getting crushed frames. What res are you streaming this at? I'm streaming it in potato resolution. I don't know how much the regular M5 how much noise it makes, but this one's pretty quiet. In my video, I do a full breakdown of the noise. So what I have here today for a little upgrade is this little Noctua device. And I think I can combine that with this thing, one of these little fans. Ian, the res is quite awful. Yeah. That's my potato stream. If you watch it later, then it will have a higher quality upload. But for now, we're dealing with potato. If you can't handle the potato, then I'll see you in the next video. But if you can, you'll be rewarded with information and knowledge beyond your wildest dreams. Okay, so yeah, this is a little 24 volt to 12 volt adapter for this little Noctua fan. Since Noctua doesn't make 24 volt fans, being able to step the 24 volts down to 12 for this little guy is going to be pretty nice. So here's the little thingy that changes the voltage. So we'll see if we can get this installed while we do this teardown, because I think that would be a pretty nice upgrade. So let's get this fan taken off. Since that's a big part of this mod. And yep, they're using Loctite. But yeah, anyone with questions about the build, just let me know and we can address those little questions you might have as we go. Alright, so here's, I gotta lower this down a little more. If only I had a flexi spot desk. Alright, so as you can see, our fan goes right here, and it blows air through all of these little fins. And this is properly designed. A lot of 3D printer companies and Hotend companies will put the heatsink in the center of an axial fan like this. But really, when you have an axial fan, your peak airflow is around the outer perimeter. So you want your heatsink fins to be there, and they've done that here, as you can see. So pretty cool design. I like what's going on there. It's based off in an aluminum extrusion. This whole piece is extruded. And let's see if we can take this whole green piece off while we're at it. It seems like the 4 screws that were holding the fan in place were also holding on to this green thing. So let me just free some of these wires. And then see if this pops out or something. Oh, yeah, it forced me to unplug some stuff. Yeah, so to get this off, you need to unplug these 2 fans. So this is a nice little piece of injection molded plastic. It's pretty heavy. But yeah, 2 tiny little fans here. They look like pretty high quality fans. And while we're at it, let's just take these fans off and see what kind of wattage they're running, because that might be of interest to a single person out there. Just one person being interested in a little factoid like this is enough for me to investigate. All right, so this is a 24 volt. All right, you probably can't read this because of my potato stream quality, but this is a 24 volt, 150 milliamp fan. So can someone do the math there? That's like 3.6 watts. These are some incredibly powerful little fans. So 3.6 watts each, and they're blowing into this little duct here. That's just really streamlined and optimized to get maximum airflow. This looks a lot like my, what was the fan duct called that I designed? The backwards sprite Hotend fan duct that I designed. This looks a lot like it. They're using a lot of smart design principles here. Basically, they're minimizing the change of angle and the amount of duct length, because long ducts end up with just wasting potential flow energy of that air. So you want your ducts to be as short as possible. And you want all your ducts to be in a row. That's the saying, right? Get all your ducts in a row. So yeah, these are just little plastic threaded screws. We just screw it directly into this little injection molded whatchamacallit. But yeah, I really like this design. I could imagine other companies wanting to use this little design because it's very efficient and cute. I think these... Wow, it's actually made out of multiple pieces here. So if I unscrew these 4 screws, there's 1, 2, 3, 4. This thing will pop into 2 pieces. And that's just for the ease of manufacturing for this injection molded part, because creating these ducts in a single piece would require a mold that kind of splits apart and goes inside of here. But really it's just a top half and a bottom half. And there's actually some dead space in there where I'm pointing on the left and right sides. You can see those portions of the duct don't go anywhere. There's just some guide vanes in there to kind of blast all of the air right into the space where the nozzle is. So this is a very neat and efficient design. Good work, Anker. And let's take a look at this Hotend / heatsink configuration. All right, so let's take a look here. They know how to make a clean package. Yep, that's for sure. Can you flip the phone so we get widescreen? No, I cannot. I cannot fix it. I tried this time and I couldn't do it, so it's just the cursed streams. Come here for the cursed streams, all right? Yep, that's pretty solidly mounted. When I yank this around, everything stays together in a single piece. So, all right, we got a better view of this stepper motor, heatsink, and Hotend here. Let's take the silicone sock off. And they put some little features on here to actually make it easier to remove. Those little flaps make it so it's easier to grab and pull this thing off. Hello, Zombie Hedgehog. All right, welcome to the stream. Zombie is a Twitch streamer. I don't know what he's doing over here on YouTube, but you don't belong here, boy. Just kidding. Everybody's welcome here. All right, so yeah, we took the sock off there, and let's take the Hotend off. So one screw here. Another screw here. So just two little M2 screws. They might be M2.5s. And then pull this out. All right, so this is pretty efficiently packaged as well. It looks a little asymmetrical, but nothing wrong with that. So let's see what we got here. I'll unplug all of the things from the breakout board. So we've just freed our Hotend thing here. And it looks like we've got a couple pins that are stuck into the heatsink there. And then on this side we've got some little holes that those pins sit inside of. Then there's the two little thingies there. So, you know, this just gets pushed in. It sits in those little pinholes. And then you've got two little screws clamping it up towards the top. Now, if I didn't know better, I would say that it appears that they're using spacers here. Wouldn't you say? They're using spacers to reduce stress on the heat break, which is an interesting turn of events, isn't it? Okay, and then we've got our little heater element here. And look, it spins freely. It's not clamped in there, it's just held in with this little screw that will retain it. And they've got some heatsink goo in there for heat transfer. And then they've got their little thermistor. It appears to be a cartridge style thermistor. So yeah, pretty neat little package here. Ta-da! Those are through holes for both of the features. So if you know anything about machining, you know that through holes are nice because you know, you just drill all the way through the block and it's easier to manufacture. So Zombie, for the last time, this isn't a ceramic cartridge. It has ceramic in it, but the heating element is I don't remember what it's called. Nichrome. Let's see. Any other good questions in the chat? I do think this is potentially something that Slice would be interested in knowing about, because this does appear to be using spacers to achieve a zero stress heat break zone. So very interesting, huh? We'll see how that pans out. Anyways, we've also got some spacers here. It looks like they're press fit into this aluminum block in the top. And just trying to wiggle these out, they're not budging. So they're probably in there pretty good. I'm guessing it's an interference fit, and they push those pins in and they stay retained into this aluminum block. And let's take it to the side a little bit. You can see there's 4 of them. 1, 2, 3, 4. And then, you know, you've got the 2 screw holes in between the 2 sets of spacers, and then the hole for the heat break up top. It's a really nice, clean design. I like it. What do you think? All right, Pezles, hello. Glad you like seeing things taken apart. All right, Dan, morning all. DB 3D Media. All right, so interesting stuff here all around. Here's the heatsink. So let's take this thing apart a little bit further and see what's going on with the breakout board and some other stuff. So I need to get a Phillips head screwdriver for this. Ta-da! Actually, let's see. I don't think this is used to hold the stepper motor onto the rest of the stuff. So I think I'm actually just going to take apart, I'm going to detach this extruder from the carriage plate there. Do-do-do. Pacha. And you can remove this whole carriage plate. There's 4 screws on the back side. You can remove this whole assembly because there's 4 screws on the back side I could undo to pull this whole thing apart. But since I want to look inside of this extruder anyways, I'll just disassemble it from this side and leave it attached to the printer. Do-do-do. All right, now that those 4 screws are undone, we can kind of pull this free a little bit. And I'm going to try and unplug this cable up top. Oh, there we go. So yeah, you can see we've got a really beefy USB-C cable right here for supplying the power. And then this is just a Bowden tube. So I'm going to go ahead and tear this off. All right, and what do we have here? So this appears to be a load cell. This thing is like a potted little load cell right in there. So this is what it's using to detect bed leveling. So when it's touching, the nozzle touches the bed, it will load this up, introducing some strain right there, and it'll detect that. Pretty interesting design here. So yeah, this is actually quite interesting. These 4 cables are going to that load cell. So I can just unplug that. Here's the breakout board. It's quite complex and dense. But let me just plug in these heater cables and stuff again so you can see where those go in. Hot end goes in right there. Thermistor goes in right there. Fan, cool. Auto bed level sensor. Hot end fan right here. And this little 5 connector wire goes over to this stepper motor and ground strap. So all in all, a pretty neat design. Looks like right here we've got a twisted set of wires that just goes up to the top and goes over here. I'm guessing that's a filament runout detection sensor. Some people were saying this doesn't have a filament runout detection sensor. I'm not sure if that's the case, because this really looks like it's used for filament runout detection. 3 wires is usually how many wires you have for that kind of thing. So yeah, interesting. Let me just get these screws out. Here's the little USB-C cable. Right in there. And that's got like this nice little alignment plug up top. So it's like a super beefy USB-C cable. That's one of Anker's specialties, is the, you know, that little USB-C stuff. So seeing that USB-C cable is pretty cool. Now this carriage plate is actually 2 pieces. I could unscrew it in the back. You can see there's 4 screws here, these little silver dots. Might as well just take it apart. You know, let's just see all the things. Oh my gosh, my my K1 Max over there isn't doing so great. I'm just gonna go cancel that print. There's something wrong with the bed leveling on that K1 Max. I think it's a code issue. Alright, so yeah, let's take this the rest of the way apart. Alright, so here's our load cell plate. Looks like a custom design. It's actually pretty neat. So the way that this works is when these 4 screws are attached to this bottom leaf, and the extruder and hot end gets attached to this through these 4 screw holes. That means that whenever any load is introduced to the hot end, it has to go through this little strain bridge. And this is spaced. There's a little. These are slightly spaced off of the surface here, so these side wings aren't touching the back. These are little like little features that are embossed. They pop out about 1 millimeter, so that provides all the spacing that you need. And I'll give you a little side view there. I always enjoy Nathan tears everything apart. Rarely do other reviewers tear into their printers to see what makes them tick. Yep, that's true. I like seeing how this stuff works. Anyone have a Flying Bear Reborn 2 in the chat? And if so, how is it? I'm waiting on a machine from Flying Bear. We'll see if I'm able to review that. I really don't like this thing after the Anker Eufy lied to everyone about the security of its cameras last year. Have to admit, though, Anker has a nice design. Yeah, definitely. I wasn't in on that whole thing. I think Linus Tech Tips refuses to work with them. But, I mean, I didn't know about any of that, so I'm just here to review printers. Okay, so let's take another look at this Hotend. So I'm not sure exactly how all this is attached together, but if we undo a few screws, we'll probably see how it works. There's a couple tiny screws there, 4 to be exact, so let's undo those. So the fact that this is running a USB-C cable up to the Hotend is indicating that we've got some kind of control chip on the Hotend. Alright, so let's pull this sucker off. And there you go. All that's behind that door is just more screws for holding everything together. So yeah, lots of screws on this thing. Alright, I think that will, those 2 screws will free this Hotend. Wow, this is a cool little design here. Looks like a little Space Invader. I mean, it's a pretty good design. Quite nice. It looks like they have a little set screw for holding on to that heat break, but it's not being used because they've got some spacers here instead. Spacers. Spacer invaders. Oops. They went full denial for months just to recognize the mistake and issue apologies. In the end, yeah. Anker, aliens, and their printers, check. Alien technology. All right. So then you can see we've got some large diameter pulley gears for driving the filament. You can see that's a pretty large diameter there. And there's a 2-stage gear reduction. We've got 1 gear reduction going from the little spur gear on this extruder over to this big gear, and then that goes to a little gear which drives these little filament rollers. That's a pretty crazy gear reduction. I think that might be the highest gear reduction I've seen on a 3D printer. All right, and then, you know, you've got some more complex stuff here. This looks like it's a bearing. And then we've got 3 bolts that are holding on to the extruder motor. Yeah, this is a sweet design. Very refined. And there's your little tensioning screw. And then this is using a cam. So a cam is a way to get a variable mechanical advantage joint. So when you get up to here, it's really easy to hold on to it. It just has kind of a premium feel to it. So what do you think about that? Pretty cool. Do we need to go any deeper? I think this is deep enough. Unlike in Creality's extruder design, it appears that these extruder wheels are doubly supported, so they're in double shear, is what we call that in engineering. On this top side, there's probably a little bearing embedded into this plastic block, and then on the bottom side, there's a little bearing embedded into this plastic block, so it's doubly supported. Likewise, this one, it's got a little bearing probably embedded in this little segment in between the small gear and the big gear, which will support it right there. And then you've got another bearing over on this side, which you can actually see. And the other thing about this is, I mean, adding to the overall level of refinement, you can see this little feature. It slots right in up here, and that guides the filament right into this aluminum piece. So yeah, pretty cool stuff there. So let's pose this question to the chat. Should I go deeper into this stuff and everything above, like over here and over here, or should I delve deeper into the base of the machine? Let me know in the comments. Also, we've got 37 people watching and only 12 likes. Come on, everybody, you gotta smash the like button. Go ahead and smash that like button. You know you want to. But yeah, this is a really refined design. Seems pretty nice, if you ask me. All right, someone wants extruder, someone wants base, non-base explanation. All right, well, let's just take this extruder apart since we're already right here. Z-axis, oh yeah, that's actually a good point. The Z-axis looks pretty crazy. The rubber V-wheels though, you know what? I don't care about rubber V-groove wheels. Everybody makes a big deal about it. It's not a big deal. Like, there's printers that have run for years on rubber Delrin wheels, and it's really not that big of an issue. All right, so here's our little stepper motor. Look how tiny it is. It's a little baby stepper motor. It's a pancake miniature-sized stepper motor. I think it's cool that they're using stuff like this because this is going to be a heck of a lot lighter than what most other companies are using. I guess it's pretty similar to the size that like the LGX Lite and other motors are using, but this is just like a traditional square shape instead of the round extruder, round stepper motor housing. I accidentally swiped up and got a video. Oh no, not suitable for work. Well, that's not good, especially if you're at work. All right, Mihei Designs, thank you. Thank you for dropping in. He's got the check mark, everyone. That's the real Mihei Designs. Not on the Z. Get tired of tightening them on first on X and Y. Okay, well, all right, so that's what's going on in here. I think we can pull this apart now. I just have to undo one last screw there, so let's get to it and just take a look-see in there. This is a pretty strange setup though, because you can see this screw threads directly into this shaft. Which is interesting. And when I rotate this, it spins everything. Also, this extruder spins really nicely, so they've kind of designed the gearbox correctly, unlike certain other companies that I could name. All right, so we take this little screw out, and this should all come apart now. Oh man. All right, so there's a lot to unpack here. Here's a tiny little Bowden tube crimper insert. This is like the smallest version of this that I've ever seen. Really small and compact. This has the little teeth that hold on to the little Bowden tube. And you can see those little teeth in there. Little teeth. That grabs onto the Bowden tube. Okay, well that's just a little insert that slots into the top of the extruder here. Then we've got this. As I suspected, it's a doubly supported shaft. You've got one bearing here on the in-between. Come on, autofocus. Focus automatically. Okay, so there's the little bearing there, and then there was another bearing on the end, and then the end of this is threaded. So pretty neat. I found that I've gotten a lot of densities on materials or roller wheels in the same package. One wheel weight was a gram or two more or less squish. Yes. Does it have a tension adjustment for the extruder? Yes, it does. So I didn't really point it out, but we'll see if we can find it here. Anyways, so here's one half of the extruder. This goes in like this, and then the stepper motor is flush there and drives that little guy. Now let's go over to the other side and see what else we got. Okay, so here's the real meat of the extruder and the extruder arm assembly. So this is the tension. You can adjust the tension by tightening that screw right there. That'll just introduce more load into that spring. And you can see we've got like a little cam here. And it's hard to describe what this feels like, but it's very, it feels very premium. When you're opening it, you get a little more resistance, and then when you get up here, it's kind of locks in position almost, and you don't have to push down very hard. So it just makes loading and unloading filament really simple and easy. So yeah, not a whole lot to this part of the design, but yeah, you can see the pins here are supported on both ends by injection molded plastic. I'll just pull this one out. So there you go. It's just a bearing on each side, and then a pin that goes through the middle. And that pin is supported by injection molded plastic parts on either side. So that's a really nice, efficient setup. That's something that Creality should have done on their design instead of using their wacky shoulder bolt configuration. So yeah, why do they make glasses with the smallest screws on Earth? Do they think we wouldn't need glasses to see them? Yeah, that's a good point. Looks similar to Creality's actual sprite extruder. I think this is a more refined, lower cost, and more effective design in general. This is a really well refined design. All right, so here's our little filament runout detector. I'm not sure who was saying this online, but someone was saying that this doesn't have filament runout detection, but it clearly does. When the filament gets inserted in the top here, it moves a little thing which like trips the sensor or something. Boop, 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 boop. All right, so there you have it. Exciting. Yeah, I'm really impressed with Anker products. They're very well engineered. I don't know about Eufy, but it was smart of them to name it something else. Smart of them to have that be an offshoot brand that isn't called like Anker Security or something. But yeah, really nice mechanical design here. I like this. So I'm gonna set this aside and put it together later. Any other questions about this? I think it's been a pretty thorough look. The only thing I haven't showed is the opposite side of this breakout board, which is equally densely populated. This is like a cell phone almost in its level of complexity and miniaturization. So there's our little chip. We'll see what is driving it. I'm gonna have to read this for you because my internet is potato. All right, so this is a G as in golf, D as in delta, 3, 2, E as in epsilon, 2, 3, 0. Then the next line is C as in cat, 8, T as in pterodactyl, and 6. Then B, S. It looks like a backwards Z almost. We'll just say it's BSG, S or 5. Oh yeah, so maybe it's BSG 5HQ JJ230L Giga Device ARM. And then there's all sorts of other stuff on here. This is a crazy little breakout board. You think they're going to open source it? Let's see some of the other stuff on here. I'm sure they have an accelerometer. Maybe some kind of CAN interface. And back on the other side, let's take a look at that. This side's mostly just connectors, but there's still a few little components on here that seem interesting. 3 peak, not sure what that is, 35 volt capacitors so that they basically won't have any issues with failing. There's got to be a stepper motor driver on here as well. Maybe it's this little thing up on the top. Crazy. Have you ever seen a board design that was this dense on a 3D printer? Here's just our little USB-C connector. And it looks like they use a fill. They used a copper pour over most of the board to help with heat dissipation. So yeah, nice stuff. Very cool. Then here's the part that everybody hates, which is the V-groove wheels. Oh no. Oh no, V-groove wheels. I'm happy to go with the SV06 Plus extruder. They have other things to get better at. Yeah, the SV06 and SV07 seem to have a pretty nice extruder setup. Oh, as dense as the Voron Stealth Burner 2209 GigaChad ARM. Any clue if it's running Clipper or has input shaping? I don't know what it's running. They might be running Clipper or Marlin, or they might be running their own thing. The thing about Anker is they're a multi-million-dollar company, probably multi-billion-dollar, and they have enough money to be able to develop their own firmware if they need to. I'm not sure what the deal is, though. All right, so that's about as exhaustive of a teardown of the Hotend as I can do. Are you entertained yet? I'm fairly certain it has input shaping. I'm gonna put all this in a box so I can put it back together later. I'll probably install this silent Noctua fan on there while I'm at it, which will be a really nice touch, making this machine even quieter. It's really not that loud. I did decibel testing in my initial review of the machine. So yeah, let me get a box so I can put this all away. All right, any questions in the chat? Now's your chance to ask all of the questions, everything you've ever wanted to know about the AnkerMake M5C, about YouTube, about all of the above. This is quite a parts bin. And overall, I'm pretty impressed with the design. It's very refined, very nice looking. Yeah. I could try and find an accelerometer on this board. But, you know, that would take some extra doing, and I don't want to do it right now. Hey, party people. Hey, R. Ballard Designs. Yes, you're welcome. You have now been educated on the AnkerMake M5C Hotend. So, I think it's time to move on to another topic, also AnkerMake M5C related. Who wants to see what's in the base of the machine? Anybody? Anyone? Bamboo, watch the extruder get pulled apart today. It looks a lot like this one. I think this looks a little bit nicer than the Bamboo Lab extruder. I've taken one apart, or I mean, at least I've held one and looked into it. And yeah, they're pretty similar, but this looks a little bit nicer. It's got the larger diameter pulley gears and is using you know, it just looks really nice is what I'm trying to say. Okay. The accelerometer is probably the little square 16-pin QFN package. I wouldn't know about that. Was there a 16-pin on there? Oh yeah, the really tiny one. It was like a square. Well, I can read what's on there. Gotta get the lighting angle on it just right. All right, that one says 6SE. Oh, shoot. It says 6S30A T. Can't tell what that is. TI. Yeah. TI2ABALPY. And it has a little dot for the orientation there. Okay, this stuff's way too tiny. Was there anything that surprised you in there? Anybody? On first configuration, did it run a vibration test? I don't know. With this machine, I just set it in the other room and pressed the button and let it print. It was very hands-off, so I don't remember exactly what it was doing. I have no idea what's going on inside of these Z-axes, but let's pull off the cover over here. Looks like we've got a couple of LEDs, some other components, some knickknacks. We've got a stepper motor cable with a grounding strap and a little, a lot of printers are using, oh. Hold on. Whoa, easy there. Easy there. My gimbal's getting overheated because I'm not using it properly. But anyways, all right, I've got enough battery here. So yeah, here's the that little breakout board that's inside the left pod of the machine. So it's got this 20-pin connector that goes from the base up here, and plugs in right there, goes into the back of the machine, which, you know, passes through over to this side, which I assume is just a connector that connects into these 24 pins right there. I don't know how to get this the rest of the way off, but it looks like it should be pretty simple, so I think we should do it. I think it's just 2 screws maybe? This might be kind of fun to run with all of the covers taken off. Just take off as many of these decorative covers as possible so you can really see what's going on here. All right, so there we go. Yeah, it was held on with that little cable mount. So we popped off our little side pods. We can see what's going on here. Yeah, it would be a nice print farm printer. USB-C port protector. All right, well, there you go. It might have some kind of pre-tuned input shaper. That's becoming a more and more attractive option because if you do like really subtle input shaping, you don't need to tune it for each machine. Okay, so they're using all sorts of best practices here from what I can tell. I'm not an electrical engineer, but this thing looks pretty well designed. We got tiny little cables here. All of these cables are facilitating connections out to the hot end through that USB-C port. Then, you know, you've got this connector in the back. Crap, I'm gonna have to take this apart too, aren't I? All right. Here goes. There we go. Okay. Oh, man, that wasn't very rewarding at all. Look at that. There's literally no new information there. Okay, so everything's on the top side of this PCB. But it looks like we've got a little test pad for 24 volt and power ground. There's a couple little components down here. This thing looks kind of expensive. Let me reattach this because there's nothing to be gained from having it detached. But yeah, we've got a really nice strain relief here. I can't tell if there's a ferrule, like a magnetic core inside of this thing. It might be a little combination piece with a little iron core. I could tell if I had a magnet. I'm gonna go get my magnet. All right, it's magnet time. Yep, that's magnetic. So they have like a little combination ferrous core thing here which just adds some line inductance. You'd have to ask an electrical engineer why they do that kind of stuff, but yeah, little inductor to smooth out the signals in those cables, reduce noise and that kind of thing. And then it looks like these are aluminum die-cast pieces that connect the Z-axis to this side here. So this little bit right there, that's aluminum, fairly certain. Yeah, that's got to be aluminum. And if you peek in here a little bit, you can kind of see the rest of that aluminum structure and how it ties in to a little block that attaches to that lead screw. You can kind of see that spiraling screw pattern there. That's the lead screw, and yeah, it's a mystery what goes on in there for now. Ribbon cable might become problematic, not really a flex item, but would be cheap to replace. The ribbon cable isn't, I guess it's under a little bit of flexing, but this is really minimal because basically you're only going to have one flex, one cycle per part that you print. And if you're printing short stuff, then it's barely moving at all. Like it's doing this, that's very low stress. That's going to last longer than pretty much any Ender 3 type cable system that I've seen. Okay, well that's that. I mentioned this in the previous review, but you've got a little cable right here. I might as well just show you. You've got a little cable right here that plugs into this breakout board, and then it goes into the aluminum extrusion, like in through this tiny little hole, and it passes all the way through to the other side, and it powers the stepper motor that's over here in the back. All that's in this other pod is just that stepper motor. It's not very interesting, but we'll pull it off, and there you go. There's a stepper motor. And there's a cable that goes through this aluminum extrusion and plugs into this breakout board over there. Not super exciting, but, you know, that works. Okay, so mysteries of the left side pod have been explored. I've only printed PLA. It'd probably print PETG just fine as well, based on what I've seen in the design. Let's see. I mean, there's not a whole lot of connections here. I'm not sure what these components are, but let me get a light turned on so I get a little bit more illumination here. All right, so got a little capacitor there. Not sure what that is. 100. All right, so this is a 6S30A TI2AB ALPY. And then there's another 35 volt capacitor here. Pretty basic circuit, and then there's a couple LEDs and this this thing. I don't know what that is. Maybe it's an inductor, maybe it's a short circuit protection kind of thing. There's your belt tensioner right here. It's just a screw that goes into a little brass nut that will pull on that that pulley idler. Hundred is an inductor, okay. Yeah, and then there's another ferrule core here over the stepper motor driver. Over the stepper motor wires. So I've seen ferrule cores in a lot of stepper motor wires on these higher end machines. So it must do something. Yeah, again, you can kind of see inside of this a little bit. It's hard to see in there though. Let's see if I can pop this off. No, that doesn't just pop off the top here. Okay, so that's that. Very exciting. Let's take a look at the bed now. CAN bus? I don't think so. Maybe it's the stepper driver I see. I don't know. All right, so here's the bed. You've got two screws right here that I assume are holding onto this wire. That's your little strain relief connection points. Those little guys right there. And then you've got 4 screws all together. Might as well just pop these off. See what's going on underneath the bed. All right, and the nice thing about this printer is there's no automatic bed leveling. There's no manual bed leveling. This is just, comes from the factory. You just press print and it does its automatic bed leveling. It automatically does the nozzle offset. I actually had to tune the Z offset a little bit. I had to change it by like 0.07 millimeters or something to get it to work, but it wasn't bad. It got the job done with the stock settings, but I just tuned it in to get nicer layer lines. on the first layer. Okay, so here's what we got underneath here. This is a injection molded, no, die cast. What is this? Yeah, it's some kind of aluminum. So this is a die cast powder coated aluminum part. It looks very nice. What do you think? Does that look nice or what? And then there's your V-groove wheels that everybody's still upset about right underneath here. I don't understand why people hate on V-groove wheels so much, but you know what? If you don't like V-groove wheels, you don't have to get a machine that has them. Look at those V-groove wheels. These crusty old V-groove wheel bed slinger machines. Nobody wants one, right? All right, and then we've got this over here, so I might as well unscrew the last two screws there and pop that off and see what we got. Oh, these weren't super tight, so maybe they came loose. All right, then let's pop that off. It's just a little plastic cover for the wire. So just a really generous strain relief here. This is a super thick cable. And it looks like we've got pretty basic setup here. There's 3 wires that are of a thicker gauge and then 2 wires that are thinner gauge. And they're really nice wires. High thread count, just like the premium sheets at Bed Bath & Beyond. And then you can see the little pattern that's used here. This is just a PCB that's been etched with this heating coil pattern baked into it. Nothing too crazy there. We'll take a look at what's under this little block. Looks like a thermistor. I probably should not have done this, but it's too late now, so let's just see what it is. This is probably the thermistor. Oh, that's interesting. It looks like they're using a surface mount thermistor. So here's the whole bed. There's our little swirly pattern going back and forth. And if we zoom in here, underneath this little foam block, there's just a tiny little surface mount component. It says it's an NTC resistor. You see that little guy? Where is it? There it is. That's our thermistor right there. So instead of using kind of a loose cartridge thing like all the other manufacturers are using, AnkerMake is using a surface mount component. All right, so it would be nice if I could glue this back on somehow. But I assume that's there to just prevent air from blowing across this and changing the reading from that thermistor. Pretty cool design choice. All right, I'm gonna get some glue. I'm gonna read some comments, see what's going on. Vibration dampener, I would guess. Heater wires and temp sensor, small wires. Main wire, this man is a wire enthusiast. Yes. All the wires. I'm guessing that yellow is just like a grounding wire. So, cool stuff. One real reason is they start getting sloppy and add something else to keep clean and wears. So the nice thing about their implementation of V-groove wheels here is that since these are machined and very precise, they're gonna wear a lot more evenly and basically wear a lot less, because it's just like having a smooth road, you know, your wheels will wear less. It's kind of the same thing. They've got more surface area. I mean, on the top here, you can see it's the normal type of aluminum extrusion. So, you know, the wheels ride on that little chamfer, which is only about 2 to 3 millimeters wide, versus on the bottom here, the grooves that they've machined into this are much wider. So, you know, the actual groove is maybe 7 or 8 millimeters wide, and the V-groove wheels are making contact with a lot more of that surface area. So that'll greatly slow down how fast that wears out. So it'll basically last longer. That's my assessment. I need to drop some affiliate links for this stuff. This is my favorite glue. For those glue enthusiasts, like Guy from Guy's Woodshop. If you haven't listened to my podcast, it's pretty fun. We talk about glue on there. So let me just glue this back in place. This stuff will glue anything. Gasket maker, ultra black, Permatex. All right, hopefully that works. And then, yeah, I mean, there's V-groove wheels down there. I don't think anyone really cares that much, but for those V-groove wheel haters, let's get a close-up of the V-groove wheels. Disgusting. Who would want a machine with V-groove wheels like that? I mean, look at that. This just looks like you're poor. Why would you want that? All right, so I think that thoroughly, everyone has a good understanding of how this bed works now. And we can put this back together. All right? All right. So this one, I'll put this back together just a little bit before we flip it over and we take a look at the inner guts inside the electronics bay. But yeah, before we get there, I'll just show you, here's your stepper mode. I mean, here's your belt. It just runs in the middle here. Then there's a little screw there for adjusting the tension if you ever feel like you need to do that. And then kind of in the back, in the back there, you can see your little stepper motor. And there's a couple exposed screws there. That's what's holding the stepper motor in place. All right. Oh, also this is, it's kind of neat how this is just one block of material. I mean, this has probably been die cast, and then they come in and do a post-processing machining step where they cut these rails into the side. So they're very precise, they're very parallel, coplanar, all that good stuff to make sure that it's very precise. I mean, people complain about V-groove wheels. I wouldn't complain about this at all. This is a really good setup. All right, so I will put this bed back on, read some chat messages, and then we'll flip this puppy over. And yeah, this is just really well designed, well put together. Excellent execution here by AnkerMake. Oh yeah, I mean, I feel like I should disclose that AnkerMake sent this over for review, and they sponsored the video that I published about it, that first video. So yeah, that makes me an AnkerMake shill. Everybody press F in the chat for me being an AnkerMake shill. So you can't trust anything I'm saying here. I would go for the Neptune 4 any day. I kind of agree. The Neptune 4 is more of an enthusiast printer. This is more of a no-nonsense, just get it and print kind of printer. And it's also got the super kind of for dummies interface that the AnkerMake app provides, where you can just tap models and download and print them without having to think. All you have to do is put filament in the machine and tap the model you want to print. No slicer involved, which is pretty nice. W in the chat. What's W? Oh no. F shill. Oh no. I guess the jig is up. I'm sorry, guys. All of these kind words I've been saying about this machine have been a lie. I think I should just be known as the V-groove wheel shill. Because how could anyone ever love a printer with V-groove wheels? All right, all of that is put back together. Then we will flip over this entire thing and take a look inside the electronics bay. Who's ready for that? So basic prints, K1, P1P, Neptune, M5C. I mean, yeah, they can all do basic prints. It's definitely true. Hashtag good chill. Okay, thank you. Thank you, thank you. Elegoo Neptune 4 versus AnkerMake M5C, and the money is a factor. Which are you picking? Personally, I would probably go for the Clipper machine, because that gives me more modding and upgradability. It's going to be more serviceable because I can replace parts with just any random old thing. Versus on this, if you're going to replace any parts, you pretty much should be replacing it with the AnkerMake approved materials. it's not really something that you're going to want to put random components into and customize. Well, I guess you could customize it. I'm planning on doing a little bit of customization. I'm thinking the power supply fan and the Hotend fan, if I can replace those with quieter options, that would be pretty sweet. And maybe a different nozzle on there. But the stock nozzle's working fine, so maybe I won't do that. Ugh. Okay, so I'm going to flip this over, and we'll start looking at this side. All right. That screwdriver is thick. Yes, this one. Ooh, yeah. It's a very voluptuous screwdriver. It's a little chunkster over there. Yeah, it sounds like most people in the chat would prefer a Neptune 4, which I have, so, you know, maybe I should do a review of that one next. Oh wait, I already have a review of it. Hey man, love your videos. Got a question for you. Do you think it's worth the upgrade €240 printer, the Neptune 3 Pro, to linear rails instead of V-groove wheels? No, I don't. I don't think the Neptune 3 Pro upgrading it to linear rails will really get you much advantage. I mean, everyone's always talking about how much better linear rails are, but there's also a lot of downsides. So I don't think that they're actually better than V-groove wheels in any significant way. I guess like lower maintenance and higher precision would be the and higher stiffness would be the alleged advantages, but I really don't see it making that big of a difference. The thing about 3D printers is that it's a very low force machine. Like if you look at a CNC machine or anything that's like industrial and designed to really manhandle material and like scrape metal parts together and stamp pieces, like that actually needs to be strong and stiff and precise. But 3D printing really doesn't need to be. There's so much inaccuracy and everything, and it's like, what's the point of having one part of the machine be super precise and letting the others be less precise? I guess one machine where it does kind of make sense is this CRM4 here, where it's got the linear rails on the y-axis, because this y-axis is super heavy. Just this y-axis alone probably weighs 20 pounds because it's a giant slab of aluminum with another piece of aluminum underneath it. So it's super heavy and it needs to be precise. So that's an application where I think it makes sense. For normal sized 3D printers, I really don't think it makes sense to get linear rails. Although there's people that have linear rail upgrade kits in my chat that I don't want to offend, so forget I said that if that offends you. Wow, that's a lot of screws here. Like from a mechanical optimization point of view, it's always better to go with a ton of small screws than to use a few large screws. Like if you look at an airplane engine, they'll have bulkheads where there's like hundreds of screws in a ring, because using a bunch of really small screws spreads out the load over a bunch more different points, and there's just a lot of advantages to that. but using fewer larger screws is more convenient in terms of assembly and disassembly. So I gotta take these wires off. All right. Ta-da! There's the base of the machine. So what do you think? There's the power supply. Oh, okay. There's all these little stiffening ribs. This is so that they can use less material in their die casting and have less issues with parts warping. These little ribs, little riblets, McRibs. All right. Is that exciting? The V6 spool, I'm not sure how that's gonna work. That's above my pay grade. Hopefully they'll send one for me to test on this machine. That would be pretty fun. Okay, but let's do an overview of all the circuits and stuff here. I'll just pull this off of the, there we go. So, all right, what do we have? There's the power supply. Everybody knows what a power supply is, right? It's one of these. You've got your power plug up top. Runs the power straight to the power supply. You've also got grounding, little yellow grounding plugs to make sure people don't get electrocuted. Here's your one user interface point, the button. That's the button right there. All right, so there's your button. There's your one interface that you can plug anything into. That's the USB-C port, which has its own little cable that goes all the way over here, up here, and into the main board. And one thing that's pretty crazy is look at that cable management. They've got these little clips. Each clip has its own little screw. They're not using glue or anything. Each clip has a screw and its own little part that's, you know, die cast in place and tapped. That's like excessive for just a single button. So a very over-engineered button and over-engineered USB-C plug. I mean, if they wanted to, they could have had the button over here. Then it would be easier to push the button. I mean, at least run the wires to the button. But they figured since most people are right-handed, they're gonna want you to put the button over there on the right side towards the front. And same with this little USB-C port. You know, most people are right-handed, so USB-C port goes on the right-hand side. I mean, Anker knows a thing or two about human factors and making things convenient and easy to use. Is a spool feeder in pipeline for Elegoo? Anybody know? I don't know what a spool feeder is. The heavy bed is the only part that greatly benefits from less friction, at least on bed slingers. Yeah, I guess so. Decreases stress rises in material also. I think that was with reference to the smaller screws. Very organized and tidy, nice base, nice bottom. No wonder I can't order a McRib. AnkerMake brought them all to reinforce their printers. It's very true. I was told there would be building robots. We're unbuilding robots here. This is a robot. All right, so let's figure out what's going on here. Okay, so this is a standard size stepper motor right here. And this is the little mini size stepper motor that they use all over the place on this machine. Standard stepper motor, mini stepper motor. Yeah, this one's a little bit bigger than the one they use on the extruder. It's longer, but it's the same like width and height there. And there's two of them. And there's those little locating pegs. Cool little features. There's the other one right there. Okay, so let's figure out what's going on with this PCB. Because this is the only PCB in the base of the machine, so this must be where all the brains are. This is the brains of the operation. Now they've got a little fan hooked up to this little heat sink. I would have actually preferred if they just sank the heat into this frame. Just use this whole frame as a giant heat sink and got rid of the fan completely. And if there was a way to get rid of the fan in this power supply and just sink the heat into the base of the machine, that would be absolutely sick. But yeah. One button to rule them all. What brand is the PSU? It is, you probably can't see this on the stream because of the potato quality and it being upside down, but it's a 24 volt, 14.6 amp, so that's going to be like 350 watts, which is like completely normal for this type of thing. Input 100 to 120 / 200 to 240. So it's got the, it's a manual switched, like you actually have to switch the voltage here between 115 and 230. But the thing is, most printer companies just send it to you set to 230. And they're like, yeah, well, you can figure it out. But AnkerMake, since they have a little bit better, more controlled of a supply chain, they know that this is going to the US, so they shipped it with the right voltage setting. I actually heard another reviewer got one of these set to 230 and they were having all sorts of issues until they actually had to open this up and switch that apparently. Because there's no way to access this switch without taking the machine apart, as far as I can tell. So, you have to take the whole base off, which involves undoing all those screws. Oh no, wait, no. You can access the little switch. It's got a little cutout for that switch right there. This is the cutout. So when this is in place, you can actually switch the voltage to between 115 and 230. But in terms of the brand, it's called the Changzhou Chuanjiang Power Supply Technology Corporation. So it's not Meanwell. It's not Creality Power Supply. It's some other party. I'm not sure if it's a quality one, but given that it's Anker and they make power supplies for a living, I kind of assume that it's probably well designed and okay. Plus this is in a aluminum base, which will help be a little less flammable. And maybe this, I don't know if this is made out of a fire retardant plastic. That'd be cool if it was. But I'm not going to test that. Just kidding, I'll test it. Let me get some fire real quick. So the extra money is in the die cast and CNC parts. That's a ton of metal. Yeah, it is. It's actually not too heavy. They've done a pretty good job of keeping things thin. I mean, it's got about a 1 to 2 millimeter uniform thickness all around, but in certain areas they beefed it up, like where these blocks attached to these towers, it's beefed up. Then you've got these little areas where the V-groove wheels ride on. That area is beefed up. So, pretty sweet design overall. Can't say I'm disappointed with what I'm seeing here. And then, holy cow, look at the amount of metal that's required to do these standoff mounts. That's like quite a bit of material just to have these. It's like, hold on. It's like these gigantic chunks of aluminum just to have these tiny little rubber wheels screwed in at the bottom. But they want this thing to be sturdy, and it really does feel sturdy. Yep, cool stuff. Tons of tapped holes on here. Like, they definitely put in the effort to make this what appears to be a high quality machine. Then we've got little brackets to hold onto the power supply. Cool. All right, let me get some. Let me get my torch. We're gonna test that. All right, we got a Project Farm fan in the chat. All right, so for this specific task, I have the fire adder and I have the fire subtractor. So that'll make sure that we're safe while we're doing this test. Yeah, one of the best built printers on the market. I would agree with that. PSU explains all the EMF suppression on the cables. Not sure what that means, but we'll go with it. All right. Time for a flammability test. We'll just do this little corner here. That seems pretty inflammable to me. So, I don't know, this seems like it's not that much of a fire hazard. I don't know if I need to test it any more than that. Are you guys satisfied with that result? If I do any more than that, I need to go outside. Also, I gotta turn my fan on. All right. So, yeah, I generally don't like burning things in here, so I gotta vent this place out. All right, there we go. That takes care of any kind of ventilation issue. issues. All right, ASM Scary wants a shout out. All right, you get a shout out, ASM Scary. 3D Puck, yeah, I'm well. Just making some live streams. Runaway test for the sound. This is a thick fan, yep. That fan is sweet. It's from Vivor. They send me all sorts of industrial goods for no reason. So yeah, I got some other things from Vivor. I've got this vacuum pump. That's for an upcoming experiment. So yeah, lots of cool stuff there. All right, so I don't know if there's much more to cover on this machine. We've run out of content. Here's our stepper motor. The only thing else that I could look at is what's going on inside of those Z-axes, but I don't want to do that because that seems like a lot of work. Bazooka cannon. Yeah, that's a crazy fan. It's a bazooka fan. But yeah, I guess we can look at what's going on here just to kind of summarize our electronics. So, that's probably our main processor unit. Let me just peel off a little sticker. So we got an STM327VGT6. Then it's 99FJ7VQ2MYS99307. RE. It ends with a little re. All right. Then we've got our fans here. I assume those are covering up the stepper motor drivers. We've got, our Y-axis stepper motor. The Z-axis stepper motors, which are probably driven off of a common rail. Well, maybe they aren't. That's actually a good thing to check. So I'm gonna get my multimeter and I'll see if these are driven off of a common rail or if they're independently controlled. I think they're independently controlled because it has this little procedure that like levels out the bed. Now I've got my little probes making the beepy noise. Yep, these are independently controlled. None of these pins are common with each other. So yeah, you got two independently controlled Z-axis stepper motors. One there, one there. And it can do a little procedure where it like touches the bed in multiple places and then it levels out that gantry. So that's cool to see. Then there's all sorts of other stuff. All right, it's almost lunchtime. What are you guys eating for lunch? I want some ideas. You think the CRM4 is worth the money over the Neptune 3 Max? Well, it really is hard to say because I don't have a Neptune 3 Max. I would like to get a Neptune 4 Max. That would be pretty sick. But yeah, here's our 20-pin connector that goes up to the hot end. We got a bunch of other random stuff here. We've got a couple cables. These are going out to the heated bed. All of these 5 cables. Very efficient wire pathing there. We've got a little fuse there. Then here's our main power coming in from the power supply, the red and black cable. And there's our wires going from the power supply to the little plug. That's where you plug everything in. And let's see what else we got. Here's maybe it's like a Wi-Fi thing. They both have little hats on to prevent electromagnetic interference. The other thing with EMI interference is if you have strain gauges on your machine, those are pretty sensitive, so sometimes you'll need to shield those. Oh, and look at that. This one has a little LCD. It's an empty port that just says LCD. So I wonder if this is the same board that they use. Sorry for the shaking. This is like, it's getting crazy here. So I wonder if this is for the same board for the M5, or if they're planning for an upgraded version of the M5C that has an LCD on it. Come to think of it, wouldn't the M5's LCD controller be mounted on the right-hand side of the machine? This might actually be indicating that they're planning on releasing a version of this machine that has an LCD somewhere on the base. All right, what else we got? I think that's about it. Oh, here's a little boot. There's a couple buttons here. Maybe like a reset and a boot button, and then a tiny little piezo speaker. Okay. This is actually making more sense now. So if you take a look at this, here is our button. This is the two cables. A button is just basically a controlled short circuit that when you push the button, it shorts the wires together. So that's what this is for. I was wondering what this is for. I was thinking, is that for the USB? But no, this is for the USB, the USB-C port. That's all your USB-C port cables. What this is a antenna. So actually the wireless antenna has been positioned over here. This is the wireless antenna. It actually is placed inside of the button. So, I don't know, did anyone see that one coming? 5 stepper drivers, I think, with 5 caps over the heatsink. Yeah, I guess that could be it. 5 stepper drivers. I guess that would be the, I'm not sure where you would get 5. Unless, yeah, wow, that would be crazy. But yeah, anyways, this is the Wi-Fi antenna. It's a little circular antenna that's like placed right underneath the button there. And I saw pictures of this in the FCC filing. So they had a ring-shaped antenna, and I was like, where is that? I haven't seen it this whole teardown, but it's right there. The reason why they can't put it anywhere else in this build is the wireless signal can't get through this aluminum base. So they have to put it somewhere underneath a little plastic base over there. That's pretty clever. Quite clever, AnkerMake. Okay. And then this little casting has a little date stamp built into it back there. There's your little date stamp. So you can see when this was manufactured, in case you cared. Imagine if someone used 2 steppers for a heavy bed slinger on the bed. Well, usually it's better to just use a larger stepper motor. Like if you look on this CRM4, it's just using a real beefy stepper motor with a gear reduction. No, there's no gear reduction. It's just a large stepper motor. They could have thrown in a gear reduction here if they needed to. Maybe that was in their design plan and they were like, you know what, we don't need the gear reduction. Or maybe there is a gear, I don't know. But they could have one if they needed one. maybe it was like, well, I don't know if we need one or not, so let's just add that little spot for a belt. Imagine if someone uses tubes. Dope stream, by the way. Thanks, Dex. I hope you learned something. I think we all learned a little bit about this AnkerMake M5C. Remember to click the affiliate links and buy one for all of your family members, especially the ones that don't know how to use a 3D printer. Do you think the CRM? Yeah, my lunch is weak. Apples, cheese, pepperoni stick, cheese, mini Ritz. That is sad. I'm gonna have to go out and get some food after this. You finally give me an idea of how to ventilate my office when I finally get a printer. Yep, just get one of those industrial grade construction site fans. That'll get the job done. 520 watts. That's listed in pascals. I don't know what that means. 373 pascals. I don't know what that is in PSI. And air delivery, 65 cubic millimeters per minute. That's absolutely crazy. This whole room, if I had to guess, is probably about 1, 2, 3, 4, 5, 6. Probably about 25 cubic, no, 25. Probably about 75 cubic meters. So this fan should be able to evacuate the entire room's oxygen in 1 minute, which is pretty nice. So yeah, I've got some other stuff in the works here. This is the K1. It just failed to print because it can't level the bed for shit. I think there's some kind of error in the code that they need to sort out. So I'll have to wait for that to get some other prints. I actually did a whole box of PLA prints here on the K1 Max. This is a giant thing. All these parts I printed on the K1 Max. This spool holder I printed on there. So it's been getting work done in PLA. It's just the bed adhesion of PLA is really good, so it can compensate for the bed leveling not being so great. But when I switch to ABS, I need a more consistent first layer since bed adhesion is always an issue with ABS. So it's just not working with it. And my regular K1, I might as well show you what's going on with that. Regular K1 over here. Follow me on TikTok if you want to learn more about this. I might upload a short to YouTube today. Wow, 375 pounds per square inch. I don't think that's right. Vivor also has some of these fans that are smaller and quieter. I might use some of those. But yeah. This is broken right now, so I have to fix it. Immediately after getting this perfect first layer, very nice print, I was like, okay, let me print out some of the old files that I printed just to see how it compares. And I forgot that this was set to 150% flow rate for the entire print job. So it over extruded a ton and then was kind of thrashing the print head around and it broke itself. So I'm gonna have to fix that. It just requires a hot end replacement. And there's my P1S. It's doing pretty good here. And this guy, planning on doing a little more upgrades on this. This is my Ender 3 that I've had for a long time. I'm going to put this Gamma Master nozzle on there. So this should allow me to print hardened materials, abrasive materials, all that kind of stuff. And this NG extruder from Micro Swiss. I'm using that because that allows me to print flexibles. So basically I'll be able to print anything on this machine. I'll be able to do, you know, abrasive, flexible, PLA, anything, except for it doesn't have an enclosure. So yeah, K1 Max has some issues. Yeah, it does. K1 Max is having issues right now. It's not leveling the bed perfectly. And I've covered that issue multiple times. But yeah. The bed isn't perfectly flat. It's good enough. Like I was able to print these large things on here using PLA, but they just need some kind of firmware update to fix the bed leveling and basically produce the bed leveling mesh correctly. I have a feeling that they messed up the stuff. Does the slice nozzle make your print patented? No, it doesn't, unfortunately. All right, well, thanks for joining, everyone. I think since we're done with the original topic of this live stream, we're gonna end it. And if you want to watch the full version, once this has been uploaded to YouTube and processes for a couple hours, you'll be able to see a higher resolution 4K version of all this goodness. So thanks for watching. I hope you enjoyed the live stream, and I'll see you tomorrow. I'll probably be making a video for tomorrow. This is the video for today, I know. A little disappointing. All right, see ya, Recycled. Thank you, DB3D. And I'm peacing out now. Goodbye.